when we get into 1.6, we're going to jump into a lot of graphing. Piecewise functions are ones you probably did not graph last year in Algebra 2. Piecewise graphs are, well, basically pieces of graphs. They're restricted by domains. Okay? For example, what happens here is that you can have multiple graphs on a single thing. You can have multiple graphs on the same, let's make it easy, x plus 1 and 2x minus 4. And these two graphs will be restricted by a domain, which means that we're going to be restricted by some values of x. So for example, we'll say this graph will work for when x is greater than or equal to 2. And this graph will work when x is less than 2. So you have f of x will equal two graphs, or two different functions, depending upon the domain. Now, you might not have graphed that last year, but you sure as heck did this. Which graph would you substitute into? Or which equation would you substitute that in? The top one or the bottom? Why? This is bigger than 2. Yeah, that's it. That's all it is. It's telling you which function to use because of the domain. Remember, this domain is that. It's a domain restriction. You're being restricted along your x values as to where you're substituting in values for. You did that part. The graphing part just looks weird. So just for real ease, I didn't give you guys any graphics, but I'll get you some here in a little bit. Just for very simple ease here. The way that I graph piecewise is I would graph this exactly the way that I would graph anything. And then I would erase where it doesn't exist. So if I'm graphing x plus 1, what is my slope? 1. What's my y-intercept? No. 1. So if I'm going to graph the top equation, I have a y-intercept of 1 and a slope of 1. So I do this. And I go both directions. Now obviously I'm oversimplifying this right now. You guys will find shortcuts real fast. Where is the only place that I want this graph to be shown? When it's more than 2. What's more than 2? X or y? X. So I'm looking for when x is greater than or equal to 2. It starts here. And now remember when you do solid or open dot?
Yeah.
Is that going to be a solid dot or open dot there? Why? And which way are numbers bigger than x? Going to the right? Or bigger than x? Bigger than 2? Going to the right or going to the left? So I connect it this way, and what do I do with all those dots? It's a domain restricted graph. It's only going to be shown for when x is greater than or equal to 2. You graph the line like you would normally and erase what doesn't work. That is the easiest, most simplistic way to graph what's called a piecewise function. Okay? If I do the other graph, 2x minus 4, where would I start that? Negative 4, and then I walk my slope again.
Your slope is 2 over 1, right?
Yep. So up 2 over 1, up 2 over 1. Now, should I go any further than that value?
No.
Why? Correct. Everybody see that? I don't need to continue it past 2 because it's at 2, it would jump to the other graph and go. So I know that I can stop here, so I can just make some other dots go in the other direction, just like I would normally. And I know I'm going to go this way, but on this value, would that be open or closed? Open. So to be honest with you, since I'm just dotting it, just make a bigger open circle over it, and that's fine. And you're going that way. It's a domain restricted graph. Yes, sir?
Just real quick, which dot is open? Is that the
Less than or greater than is open. Greater than or equal to, less than or equal to is stop.
okay.
Okay? It's very simple stuff. Last year in Algebra 2, I don't think anybody did that. It was a section that we cut out, and then we realized we really should have had that in there. So, when we start the full-on graphing stuff tomorrow, you will see some piecewise functions. What we will see tomorrow will be something like this. Let's see, what was it for x is. Let's look at this one. Instead of being two linear graphs, you might have a quadratic as well as a linear function. They'll mix and match them together, but you still graph them exactly the same way. When you guys first learned to graph, what was the easiest way known to man to graph? Or what was the first way they told you, I should say it that way? Start with the T and that's an able.
Table.
Very good! Okay. You picked numbers that were easy to work with, especially with quadratics. Linear functions is a piece of cake. Slopes, intercepts, and go. Now on this one here, if I'm going to look at plotting out my cube, or it's not cube, square, I know I'm going to have to be less than or equal to 1. Okay? So if I just pick 1, I can start with that point, right? What's 1 squared?
1.
What's 1 minus 3?
-2.
So at 1, it's -2. And I know that's going to be a solid dot because,
It's greater than
correct,
equal.
less
Yeah,
than.
I was just.
Now, that means which direction of the number should I be picking now?
Negative 4.
Well, what's the next number?
0.
What's 0 squared?
0.
What's 0 minus 3?
-3. And then you just going down to
Yep. You'll notice that you wind up, if you remember the axis of symmetry, this one is symmetrical about the x-axis because there's no x term there. It just has a y-intercept of -3. So I know the next point would be at, okay. And then might as well use any other number. What's 3 squared?
9.
Do -3 squared.
9.
What's 9 minus 3?
6.
6. So if I just skip over a couple and I go to -3, I know it'll be up here at 6. So I know that I'm going to have this bit of a curve.
So this is like this is a parabola.
It is.
But you
It's
can't finish it because it's a domain restricted.
correct. Very good. It is part of a parabola. It's restricted by the domain in a piece. So it's part of its pieces. So we've done the one part of the graph. We do the other one, 2x plus 1. Where does that start?
1.
1. What's the slope?
Well, wait, I think you can start right there. Wait,
I know. What I'm doing here is the oversimplified version of it. If you do it this way, you will be less likely to screw up in the long run. I just have to go back and look where my restriction's at. Where's my restriction?
1.
At 1. So when x is 1, I know that this dot can't exist. But what should I do to that? Open it. And like I said, if you just over-exaggerate with an open dot on there, I'm fine with that. Okay? I'm perfectly fine. And I know it's got to go this way. 1, 3? I just started with the regular slope-intercept form. I started at 1, walked my slope. That's all I was doing with the line. Linear stuff, I'm just going to go point, or slope-intercept, if it's already in that form. Or I'll do zeros and stuff like that. It's just, I'm just doing real fast graphing. And I go back and I erase where it doesn't exist. That's piecewise functions, ladies and gentlemen. It's silly, silly simple. It's just the idea that I know that most of you haven't seen that. Or am I right in saying that none of you have seen that?
Yeah.
Because I know we didn't do it. So, you skipped it. I have a few of these for you guys to look at. Do you guys still have open graphs on your graph paper you got? Okay. What I'd like you to do tonight is just 1 through 18. Because then there's 6 graphs, and you guys have at least 6 open spots, and you don't need to do any more than that. I think I counted wrong. Go figure.
What you want us to do now?
Yeah, because the first 12 of these are just function notation. Get you back in the idea of what function notation looks like and how you use it. And then I just want the 13 through 18, those next 6 are just graphing it. Graphing the piecewise function. Being able to go through the domain restriction on your own and plot it out. Okay? There aren't any non-linear functions here, so it shouldn't be that crazy. Tomorrow when we start our graph pack, it's kind of, I'm going to let you guys go through a bunch of graphing a little on your own. I'm going to do a little bit of, bless you, a little quick linear review, quadratic review, exponential review, cubic review, but it's all with dealing with numbers that are easy to work with. Having to remember what perfect cube roots are, perfect squares, things like that, easy stuff, okay? Yay. Sir? Go 1 through 18 on that, please.
On the B or C?
Oh, is there 2 sides? I didn't realize there were 2 sides there. Yeah, on the B side, sorry. We'll do the B side. Okay? On the B side, sorry. Okay? I didn't realize they ran off a double-sided one there. What's that? We will. We will. Step functions are so simple. They're so easy. It's they use it. It's the greatest common integer ones they use it for. Your calculator, all that kind of stuff does it. You guys will fly through them. You will.